Hello students, welcome back to another class on complex analysis, and we are going to see an introduction to the complex analysis, and it may be useful for the fourth year of the BSc Honors or the first year of the MSc courses as may be suitable for you. And this being an introductory course, you can follow from the beginning all the basic concepts, and in continuation we will be seeing problem solving as and when it is applicable. So let us start with the terminology and then see an appropriate example of some of the theorems. So we start like this. First you have some kind of standard notations and terminology. You have the so-called Z, which is reserved for a complex number or complex variable. If you have numbers like 3, 4, etc., then we say a complex number. I have written Cn here. So it's a particular number, you can't change it. But however, if 3 is any variable, so why only 3? We can also have 7 or 9, right? So instead of 3, I can put some x here. I is a square root of minus 1. That's a complex number you have. Maybe I will write down here. In this expression, I is nothing but square root of minus 1, which we call the imaginary number. And then this 4 is any variable. There is no compulsion that you should have only 4, and therefore the 4 has been changed to y. So if you write down z equal to x plus iy, then the complex number becomes complex variable. So difference between complex number and complex variable is clear. So if that is the case, we are now going to talk about the function of a complex variable. So you see this, the complex variable is clear. I have an x plus iy. So x plus iy is the complex variable. I want a function of, so I'll write down that. So function of the complex variable is what we say conveniently f of z here. So instead of writing f of x plus iy, it is convenient to write f of z. So therefore, you have the understanding that f of z is a function of complex variable. So I will write down like this. It's a function of complex variable. So just note down Cn, Cv and Fcv. Fcv means function of complex variable. So we are going to discuss more about the function of the complex variable, because typically only z and the complex variable most probably you might have done in your higher secondary course or in the very beginning or first year of the BSc. So now that the title is complex analysis, which means we are going to analyze how the function will behave. So where is the function? This is the function. This is the function of the complex variable. So how the function will behave, that means whether the function will diverge to infinity or it decays to 0 or it oscillates, or can we differentiate the function of a complex variable? Can you integrate? Whether those functions have those properties? That's a question that we have, and the answer to these questions are addressed by a subject what we call by the name complex analysis. So formally it is also known as the theory of function of a complex variable. Okay, for short we can also call by the name complex analysis. So that's an idea. Now there is another point which is very important, that from the school you have been learning that x plus iy can also be rewritten like x comma y. That means this I is just a square root of minus 1 which is getting multiplied. The point is that x is a real number, y is a real number. So two of the real numbers are added with a square root of minus 1, and then we say that the number becomes complex. That is how the tradition is. Therefore, both x and y are real numbers. So how do we write real numbers in mathematics is x belongs to real numbers. So there is a double stroke r. So you see that there's a double stroke. This is double stroke. And then you complete the capital R here. So if you do that, this represents a set of all real numbers. That's a notation. And then y also belongs to. So that means y is a number taken from. This is the meaning of taken from. Y is a number taken from the set of all real numbers. X is a number taken from set of all real numbers. That means it is one number taken from that set. So instead of writing two separate lines like this, we can also write like this. So rather than writing two separate lines, you write it in a single line saying like this: x comma y, both of them belong to, or we say it is they are taken from the set of real numbers. So this is what we mean to say that x comma y are real numbers. So the moment you say that you add it like this x plus iy, then what happens is after the addition this becomes a complex number. So therefore, in this particular style, if you want to write down, we say that z is belonging to, or we say that z is taken as a complex number. So complex number is also written like a double stroke C here. So just like double stroke R, you also write down in double stroke C, and this is the standard notation that we have. So you have to be clear with these notations. X and Y are real numbers, Z is a complex number. This is the notation, and once you have this standard notation, it is also clear that the function of the complex variable is also in general belongs to the complex variable C. So the function of the if Z is belonging to a complex number, function of the complex variable is also complex in general. So therefore, these are the some of the notations that we have to be clear, because when we are going to solve the problems, or when you are going to look at some of the questions that are asked in the GATE exam, they use the notations rather than explaining them. So the notation should be quite comfortable for you. So that is the point, and these are the notations which are very important, and we will be repeatedly using the C and capital R, which are double stroked. Fine. Now the first thing is that before going into the function of the complex variable, let me explain some basic idea about how the function is looking like, what the function is going to do. So let us see, we'll take a small example here and let me explain. So take for example the first example itself. Let us say that let us consider z equal to 3 plus 4i. How do I represent it? So you know this because this representation is there right from your school, so it is very convenient for you to understand. So you draw this x and y, but now you don't call this by the x-axis and by y-axis. This is what is the change. Don't call this by x-axis, but you call it by the name real part of z. So you see this, you can easily see that z equal to x plus iy. If I write like this, what is the real part of x plus iy? Only x is called the real part. This is the real part, and that's the imaginary part. So I can say that x is, what is x? X is the real part of, so let me write down RE, real part of x. Okay, whether you write square bracket or the usual bracket, that's fine. You can also write down like this. It is a real part of, sorry, z, right? That's the z. It's a real part of the z. So z, you put it here, take the real part, and that is nothing but x. Similarly, what can you say about y? Y is the imaginary part of z. So this is to be used frequently. So we will not call by the name x-axis, y-axis. So don't call it by x-axis, y-axis. You call it by the name real part of z and imaginary part of z, and that's what you are going to show here. So I will write down like this. It is the real part of z. And similarly here you write down that this is the imaginary part of z. So this is the standard notation. We will not call by the name x-axis, y-axis. So this is some of the terminologies, or what is the style in which you call each one of these objects. No? That is very important. Now once this is clear, now what will you do with 3 and 4i is, 3 is along the x-axis, so you can say that okay, this is 1, 2, 3. So let us say that that is 3, and then you have around the 4 here, so 1, 2, 3, 4. So if you find out the point, and that's the point that you have. So that is the point which is represented by 3 plus 4i. This is quite familiar right from the school. Now what is that we were interested to do is, you will consider, let us see what will happen if you are going to consider a simple function. Let us say that I am going to consider a function f of z which is given by 1 over z. Suppose if there is a function of a complex variable like this, then what will happen to this in this particular graph? What happens to the function? So this we will discuss without referring to numbers. So here you have 3, 4, etc. Right? Let us not consider any number. You simply remove this 3 and say that that is your x, and remove the 4 and say that's y. What it means? It means that this particular function can also remove this 3 here. So the function is in general represented by x comma y. we say that there are x number of units here along the x-axis or y number of units here, so that this is your x comma y point. That's clear. Now, what is that question? First, let us understand what do you want to do. Okay, this is the complex variable. This is the function of a complex variable. What do you want to do? So the question is that we are interested to ask the question, what happens to the z? So let me write down here. What happens to z equal to x plus iy under the map let us say f of z equal to 1 over z. So that's the question. So question should be clear, then only we will be knowing what is that we are doing. Okay. So there are some technical words which are coming into picture. Map. Map means function. That's all. There is function is the familiar name right from school, but map is more technical word in mathematics. So we say that this function of complex variable is called the map. There is nothing more than that. So f of z is called the map, and the map is given by means for this problem it is defined by 1 over z. That's what is given. Suppose if you have a function of a complex variable and the function is defined as 1 over z, what happens to the complex variable x plus iy? That's all about it. That's the question, and we can discuss the answer the following way. So how are you going to discuss? That's what we are going to see, and you will surprisingly you can see that the solution method is so simple, and this question has been asked in the GATE examination. So you can see that the discussion looks so simple, but still the simple questions are asked in the GATE examination. So you'll have to remember that these are important. Now the discussion of this particular solution starts with a very simple idea of the modulus of a complex number. So let us now consider the modulus. So how do you write modulus here? This is one way of writing down in the Cartesian coordinates. This is fine, there is nothing wrong, but still it will be better if you can consider the polar coordinates, because you can always consider like this. Why you can consider is because of the Euler's formula. The Euler formula, you see this, let me therefore expand this e to the power of I theta by the Euler formula, which is nothing but cos theta plus I sin theta. So e to the power of I theta is cos theta plus I sin theta. This R simply write down here, and that product is this z here. So which means that R times cos theta. So you have R times cos theta which is there here, and plus I into R times sin theta. And what is R times cos theta? X. And what is R times sin theta? Y. So therefore, you again get back z equal to x plus iy. So technically, this is very well known to you. Z equal to x plus iy can also be rewritten in the form R times e to the power of I theta in polar coordinate system because of the Euler's formula. So this is what you need to know. And once you know this, there is no need to write everything. You straight away write down that this quantity is the z. So this portion can be removed. So therefore, I will remove this. So now what we are going to say is that in the case of the polar coordinate system, z can be written as r e to the power of I theta. If that is the case, how do we take the modulus? So modulus of z in this case is equal to the modulus of the entire thing, that means the whole thing, which means the modulus of this into this. So that means modulus of r into modulus of e to the power of I theta. That's how we write down. And therefore, how do we simplify this? This is nothing but modulus of r. This is equal to 1 here. This is equal to 1. Now how this is equal to 1? That is quite simple. Of course, simply I will explain one step how it is becoming 1 here. Maybe shall I write here, for example, because of this definition, you know the definition. What is the definition is? Modulus of z square, this modulus of z square is given by z into z star. So that's a standard definition you know. Now you apply that definition, and then for the e to the power of I theta. So z is r into e to the power of I theta. Fine. Then what happens to the z star? For z star you will be getting r into e to the power of minus I theta. Because r is a real number. Since r is a real number, when you take the star, namely complex conjugate, nothing happens to the real number. So you will get back the same r. Whereas every I will be replaced by minus I when you are doing the star operation. Isn't it? Complex conjugate means every I becomes minus I. So e to the I theta will become e to the minus I theta. So r remains r because it is real. So therefore, if you multiply this, you get r square. So that means this product, what I mean to say here 1. So here you have a 1, I am explaining why 1 came here. This 1 is nothing but, you see here, this 1 is nothing but e to the power of I theta into e to the power of minus I theta. So that's the product that you have, and therefore I am having a 1 here. So that is the reason why you got a 1. So ultimately you are getting this expression, namely modulus of z equal to r. And in fact, you see that this modulus has been removed. Now let me explain this. On the right hand side, how can you remove this symbol modulus here? R is a real number. Okay, is it greater than 0 or less than 0? You think whether it is greater than 0 or less than 0. When you have a polar coordinate system like this, what is r and what is theta? So r should be something like this, that's the point, and theta should be like this. So that is theta, and this is r. So r is the distance from the origin to the point. It's called the radial distance. Can it be negative? Is there any option that a negative value is possible or not? It is starting from origin, and then it is going to some point, and that's a distance. You can't have a negative, because even if you are going to this direction, let me tell you what happens if you are going to this direction. For example, if there is a point here, then there is an angle here. Even then, this is also plus r only. This is not a minus r, because the distance has to be measured from the origin to the point. So starting point is here, and then ending point is there. There is no negative value. So it is technically, it's nothing but it's the radius of the circle. So because of that reason, negative values are not possible, and since negative values are not possible, modulus represent without modulus. Okay, the purpose of the modulus is to tell that you have to take only positive value, but since a radius is already a positive value, there is no point in putting the modulus. So therefore what happens is, you finally write down that mod z equal to r if, when this is true, if z equal to r e to the power of I theta. So this is another important conclusion. So let me put a line here. So that line is there. You keep this important line, that as long as you consider z equal to r e to the power of I theta, we make a conclusion that the modulus of z equal to r. Now this equation, modulus of z equal to r, is really interesting to discuss more before going into the solution. Okay, let us therefore discuss what is the meaning implied by this equation. We can quickly find out what is the meaning. Now what is mod z square? Mod z square is x square plus y square, and that is the relation that you get it from relation between Cartesian system to polar system. That's this relation, and that is equal to, you have an r square here. So you get some equation. This equation you might have seen somewhere, maybe in coordinate geometry. You learn some straight line, circle, parabola, etc. Do you remember what is x square plus y square equal to r square? Certainly you know that it's a circle. So this equation represents a circle whose center is 0 and whose radius is r. So that's the meaning of this particular circle, which means that you can actually draw like this. And then what is this x? This x is nothing but real part of z, and that y is the imaginary part of z. Once you represent like this, and once you draw the circle, the center of the circle should be the origin 0, 0, and then this is r square is the radius square. So this radius should be equal to r. So that radius that you have is r. So this equation of the circle, now what is this circle represent is, the equation of the circle, we therefore plot like that. This is, you can write down like this, equation of circle is, the equation of the circle is, rather than saying x square plus y square equal to r square, you say that mod z equal to r, isn't it? So what is the equation of the circle? Finally our conclusion is that we don't want to write down like x square plus y square equal to r square. but rather we are interested to write down like mod z equal to r. And that is the important conclusion. So the moment you see mod z equal to r, this represents a circle of radius r whose center is 0. So therefore, the center is 0 is not visible here. In the sense, if you want to make it visible, how do you write this equation is, you can always write down that modulus of z minus 0, isn't it? That is equal to r. So this tells you that 0 is the center of the circle, isn't it? So if 0 is not the center, if you want to move, see, you have this particular circle. I can move this to the right side, or I can move to the top, or I can also move somewhere here. You can move the circle anywhere. So in case if you are going to move the circle, then the equation of the circle will look like modulus of z minus z naught would be equal to r. So now therefore, according to this, let me draw the circle. Maybe here I will draw. So if I am going to take this, suppose if I am going to take this is the real part and that's an imaginary part, I can draw the circle here, and that is the center. I'll say this is z naught. This is the origin. As you can see that that's the origin that you have 0, and z naught is here, and the radius is r. So it means that this circle which was at the center has been translated, has been moved to another place z naught in the complex plane, and at about that point the circle has a radius r. If that is the situation, the equation of the circle is this. So that is the equation of the circle. So that is so we say that, I don't know whether you like this arrow or that arrow. So I'll write like this. So this circle is, what is this equation? So I say that is the equation of circle. So before going to further, just I would like to refresh your memory. Again, you come back to this Cartesian system, x square plus y square equal to r square. This equation represents the equation of the circle centered at origin. Okay. Suppose you don't have origin, somewhere else you have, how the equation will look like. Simply refresh your memory. It may be there in school book or higher secondary, or it may be in the first year BSc coordinate geometry. But I will write down the equation for your refreshment of the memory. So the equation of the circle is like this. So general equation of circle, as usual we have an x square plus y square, that is the requirement. Okay, x square plus y square should be equal to radius square. So certainly x square plus y square will be there. Then I need center. Okay, what do you mean by center? Center means some x comma y, isn't it? Some x and some y is there, means I can put a point there, and that's the center. So I need terms containing x and y. This doesn't contain x and y. This is x square and y square. So I need terms which are proportional to x. I need terms that are proportional to y. Then only I can get the center. So the terms are like this: plus 2gx plus 2fy. That's a 2 here. So that's a 2fy. Okay. Is that correct? 2gx plus 2fy. And plus this constant will give you the radius, and that is 0. So this equation is easy to remember. First two terms are required, then only you get a circle. This g and f will tell you the center of the circle. This constant will generate the radius. And that's all about it. So it's easy to remember. Now once you have, this is the general equation of the circle, we can quickly write down what is the center of the circle. So center of the circle is given by minus g comma minus f. So you simply find out what is minus g and what is minus f, and that's it. That is the center. And then the radius of the circle is given. It will be given by a combination of g, f and c. So let me write down this. So this is g square plus f square minus c, and that's it. So this equation is very important, because this equation, this is identically equal to, this equation is what is written in the complex variable theory, like modulus of z minus z naught is equal to the radius r. Okay, so that's what you have to understand. This is become this equation. Okay, this is the usual Cartesian coordinates or coordinate geometry that you study, this equation has been rewritten. Both are same actually. Here the radius is directly given as radius. In this case, radius is not directly available. It is available in another constant. You have to do this calculation to get the radius capital R. So this is the complex version of the circle. This is the real version of the circle. Okay. So this information, whatever I told you, is required in order to analyze the question that we have discussed. So we have the question, we'll see the answer later. The question is, what happens to the variable z equal to x plus iy if we are going to consider the map f of z equal to 1 by z. Okay. For that, this is required. So we will see the answer in the next class. Okay. Thank you.